supaya Okay, work and energy. Now let's talk about work done first. Okay, I have an object of mass 5 kg, and then I apply a force of 10 Newton. Due to the force, it moves 5 meters. In this case, you have a force and then you have distance. Now, one very important condition is that your distance and your force must be parallel, okay, for work to be done. So I apply a force of 10. Due to this force, it is coming in this direction, parallel with the force, both are horizontal. Then work is done by the force. By who? Again, the force is doing the work. So work done can be defined as force times into distance. Now, 这个两个一定要 same direction. Let me rephrase again. Not necessarily same direction, but they must be parallel. Okay, they must be parallel in the same line. So in this case, I can calculate how much work have I done since I'm the one applying the force. So 10 times 5, okay, 50 joules. 50 joules of work I've done. Now, this work done is a positive work done. Positive work done is when your force and the distance is same direction. Now, when I push this one, right, let's say the surface is a rough surface, and then you have frictional force. The friction is 2 Newton. The friction is applying a force against my distance. So work is also done by friction. We can calculate work done by friction equals to 2 times 5, okay, 10 joules. This is negative work because it's different direction from the distance. Okay, very simple. Same distance is, same direction is positive work, different direction is negative work. Now, when we got the work done, what does it mean? The 50 joules. When I say, what does it mean when I say I've done positive work on the object? If I've done positive work, think of it like I have added kinetic energy to the object. Positive work done means I have added kinetic energy to the object. Negative work means I take the kinetic energy out of the object. So work done is basically equals to the change in kinetic energy. Okay, you want to take this down? Work done is change in kinetic energy. Positive work done, 我放 energy 进去. Negative work done, 我拿 energy 出来. Okay, very simple, like this. One force, I got 2 forces here. I'm doing positive, the friction is doing negative. So overall, is the object gaining kinetic energy or losing kinetic energy? I've done 50, it takes 10, so it's gaining 40. Since the object is gaining 40, so the kinetic energy increase is equals to 50 minus 10. Okay, we got 40 joule. What is the formula of kinetic energy? Ke equals. First of all, what is kinetic energy? Kinetic energy is energy due to movement, motion. When you have speed, you have kinetic energy. If you have 0 speed, you do not have kinetic energy. So your equation goes like half mv squared. Depending on 你的 kinetic depend on 你的 mass 还有你的 velocity. 还有 square 在 velocity 意思说它 much more dependent on velocity. Okay, Ke equals to half mv squared equals to increase is how much? 40, right? Now, we know that this object increased 40 kinetic energy. What is the initial kinetic energy? The object started from rest. meaning that the initial speed is 0. If I calculate initial kinetic energy, mu squared, okay, this is half m 0 squared 0 joule. This is KE initial. KE initial is 0. KE final is 0 plus the increase of 40. So 40 joule. Okay. Now we got the final kinetic energy. Then we can calculate from this equation what is our final speed of the object. Half mv squared equals to 40. Half mv squared equals to 40. So 4 squared 40. Okay. V 等于40。Okay, calculate. 4 meter per second. This is the final speed. That means this one comes here now having the 4 meter per second. Okay, final speed. So what is work done? Work done is the change in energy. Remember that. Whenever I do work, there must be a change in energy. I'll give you another example. Let's say there's a total of 100 joule of energy in my body. 100 joule. The environment got also 100 joule. And then I do like this. I rub my hand. So what I create is heat energy. Huh? So the heat energy, let's say 20 joule stays here. I do rub my hand. Then I create 20 joule of heat energy. Then I let go like this. The heat energy escapes to the atmosphere. That means my body minus 20, how many left? 80 joule of chemical in my body, chemical energy. Then the 20 transfer to the surrounding. Here plus 20, now got 120 joule. The process of the transfer is the work done. Okay? The process of the transfer is the work done. That's why I say whenever work is done, energy must be converted. From what to what? Okay, in this case, from chemical to heat energy. In this case, from the kinetic energy. Okay, that is the relation between work and energy. Now, one thing for work, 刚刚我们讲我们的 condition 是什么？你的 distance 和你的 force 一定要 same directions. So let's say I carry box weighs 5 kg up the stairs 3, 4, 5 meters. How much work have I done in this situation? How much work have I done? Carry, so you have a force of 50 Newton. Need a force of direction, label it correctly, upward. And then I'm moving this distance. Is this distance same direction as the force? No, it's not parallel. So can I take this distance? Cannot. Which distance should I take? The vertical distance. So when you calculate work done, W equals force times distance. This one with this one. 200 joule. Okay. This one we cannot take. This one we cannot take. We only take the vertical distance. So again, the distance must be same direction as the force for work to be done. If I apply a force to push this wall, but the wall doesn't move, no matter how much force I apply, the wall doesn't move. Is that work done? No. You may argue that, okay, I apply so much force, but still the wall doesn't move. According to definition, this is zero, you have zero work done. Again, example like the sun goes around the earth like this. Sorry. What kind of word is this? Earth, sun. Okay. Gravity like this, right? Is the sun doing work on the earth? Is the sun doing work on the earth? Is the sun applying a force on the earth? Yes. Is there distance travel? Yes. Distance travel is in circular, right? Is the distance parallel to the force direction? No. Is there work done? No. So the sun asked the earth to come here, but due to whatever reason, it doesn't want to come here. This force is not creating any distance. So the sun is not doing any work on the earth. Right? There's no work done. In this case, you got force, you got distance, but still there's no work done because distance and force not in the same direction. Yeah. Right. So let's say you use back the same example. And this time we say the object has initial velocity. U the mid. Okay, 10 ms minus 1. Same force I applied, 10 Newton, 2 Newton friction. Initial velocity of the box is 10. Initially it is moving. Okay, what is the final velocity here? Then calculate. What is the work done? W equals to force times distance. 我有两个 work 啊，一个是我做的 work， 一个是 friction 做的 work。我找 net work 是多少钱 ？Net work done is net force 乘 distance. Net force is 10 minus 2 times into distance traveled is 5 meters. 40 Joule. This is my net work, right? So net work is a positive or is it a negative? It's a positive net work, right? The increase, the positive is more than the negative. So overall, there's a net increase in the what? Kinetic energy. Okay, we work done kinetic energy. So overall, there's an increase in the kinetic energy of 40. Now, initial kinetic energy is KE initial R 5 times square 150 done by initial. Okay, KE initial plus the positive network, so 40 being added, KE final. 40 plus 40, 290 Newton. Now you got the final kinetic energy already. So when the box come here with the final kinetic energy of 290, now I ask what is the speed of the box over here? Up mv squared 290. Okay. 5 v squared 290. That's how you get. Okay. Anyone? Any question? Yeah. So, 这个 force 我们 assume 是 constant force. It's a constant force. When I pushed it, it doesn't change. What if these forces change over time? Our formula W equals to mv. This is you can only put one value inside. This is when you calculate. You use this when force is constant. You can only put one value inside. What if this is a variable force? variable force meaning that when I push it, sometimes I increase, sometimes I decrease, sometimes I increase. Then how do you calculate the work done? If this was a variable force, then you should have a graph of force against time to show how your force changes over time. Okay, let's say 10 Newton. Okay, so in the first 5 seconds, I pushed it with increasing force, then drops. Okay. How do I calculate the work done? There are so many values of force here. At this time, I'm applying this force. At this time, I'm applying this force. This time, I'm applying this force. The force keeps changing. Work done is calculated by force term distance. How do I calculate this one? Just one value. So I will take the entire area of the graph. Okay. So the area of the FT graph is equals to your work done. Human force term distance, y-axis term, x-axis, which is your area. This one is area of the graph equals to work done for a variable force. Right. 先做 question 1.那个 graph 最后一 part。OK， 那个 graph 是，如果你的 force 是这个哦，刚刚的 example 我们 assume 它是 constant 10。OK，I apply same force。然后在另外一个情况，如果我的 force 是变来变去的 variable force 啊，有时候我带5，有时候我带2 ，then you should have a graph like this， 就是它会 show 你的 force 怎样 change over time。Right? So in the first 5 seconds, maybe you increase the force from 0 to 10. I push faster like this, harder. In the last 5 seconds, I decrease my force. So overall 来讲，我的 force 是变来变去。Right? So 在那个情况下，你怎样找 work done？ 我们找 area under graph。因为你的 work done formula force time distance， 这个是用 for constant force 的，你只可以放一个 value 进去罢了。可是我这边有这样多个 value force 变来变去的嘛 ，changing many values. I cannot use this formula already. What I can do is I will take the area under the graph is my work done. OK， 只是 for variable force， for 会变的 force。I want 5.
等一下啊，要把你这个状态学生简单，就这样才能念
这水不就是3个3个
啊，就上三个，
我们
这个是三个，啊，对，这个是三个，然后Okay, A work done by force F. OK， 它只是用 F 的 work done 到的。That's why 我们只是拿这个 force。You have to cross it and make it the same line as the distance. Must be same direction. Okay. B. The work done by the friction. So the friction W is equals to 3 times 2, 6. 啊，这个是negative，是我们放 negative 6 joule。哎，那个 negative 从哪里来的？其实是从你的 force 来的啦。Force left side, right? So this one we need that is minus 2. Because force is a vector, so minus 3 times 2, you get minus 6. Negative work. Alright? Yes. Hi, yeah. Okay, see the work done by the weight. Weight is downward, distance is to the right, nothing, 0. D by the reaction, same, reaction is upward, distance is to the right, so 0. Total work done. What's the difference? Okay, you're trying number 2.
来，你们要做吗？第二，anybody got answer ready?
What is the work done to bring it to stop? OK，来，我们先找 W F 乘 D 对吗？Distance travel is this one, horizontal, but it's not given, huh? We know the force is this one, 5 Newton, okay? So that means, can we find the distance first? Can we find the distance first? Okay, distance traveled before stop. U 10 A not sure, V 0, distance not sure. Then we get the A. Friction 是5 mass is mass given 2 kg. So F the D and A direction is supposed to divided by 5 divided by 2 kg. 2.5 ms minus 2. Put it here. Now you find the distance. Okay, since the acceleration then now we will acceleration actually is deceleration 2.5 slowing down so deceleration of 2.5. Now I got initial final velocity is 0. I use that to find the distance traveled before it comes to stop. UAV, so V square, U square plus 2AS. Zero square, U square. Direction is minus 2.1. Okay, do number 3, we discuss. Okay, 还要找的是什么 determine the work done by gravitational force. Question 3, determine the work done by gravitational force. So gravitational force is the weight. You want to find the work done by this weight. Where is your distance? This direction. So 你要 resolve 你的 force 去这个 direction. Okay? So again, I want to calculate the work done by now. 你的 work done 你要注意它是 by 谁啊 ？by 什么 force？ 它可以是 by friction， 它可以是 by the pushing force， 它可以是 by weight or by reaction. So depending on work done by who is doing the work. In this case, who is pulling this one down? The gravity, right? The weight. So weight must have done some work. How much is that? We take the weight, which is 1.5 times 10. And then you resolve to this one. So here is 1.5 times 10. Sine, answer. Same direction, parallel to the distance traveled. Okay, so you work answer. So sine 30, that's from 20. Okay, fine. 啊，这个这里是30，好吗？这里的 angle 是跟这边一样的，这样我要把这个拉去，哎，你把它想成这个是你的 y axis，这个是你的 x axis。OK，我再 resolve 这个啊。This one. This one I resolve to the x-axis. I'm moving away from the angle. If I'm moving away from the angle, then we will use sine. If I'm moving towards the angle, then I will use cos. 如果我要找 y component 的30 cos 30这个 sin 30啊，所以你 cos 那个 angle 就是说你 move towards 那个 angle， 你 sin 那个 angle 你 move away from this angle。You remember that one? You do it faster. Okay. Of course, you can draw the triangle if you feel like that one is more easier. You can draw the triangle out, or you can just use sine is away, cos is move towards. OK， 可是你首先你要先画你的 axis 呢，你的 axis 是 parallel to 这个 slope， 你的 x axis 和你的 y axis 是 perpendicular。OK，你有了你的 axis， then you cannot move away or towards the angle. Is the sine or the cos. Okay, W is 多少？184 184 joules. Is it a positive word or is it a negative word? The weight is downward, right? The weight is downward. After I resolve it, it's pointing in this direction. So same direction as the distance. That is a positive word. Positive. Same direction as distance. Positive words will increase kinetic energy. So the speed down here will be greater than the speed up there. I'm doing, who is doing the work again? The gravity, the weight, which is the gravity pulling it right, is doing work of 184. That means the gravity is adding kinetic energy to the box, 184. When it slides down here, the speed should be greater. 对吧？有问题？哪里？哦，
187.5
啊，是啊，
，Yeah，
187.5 ，OK。哦，因为我用9.81，呀，187.5 ，OK，right。对，来第4题你会做的第4。Know how to do number 4 and number 5 also.
Dùng vô đanของมันบอสสุภาพสาวที่ว่าแต่จงรู้รู้ด้านของบอสเลยก็ต้องทำเลยเดี๋ยวมันจะเป็นแบบอะไรที่เป็นไม่เราเป็นอะไรที่เป็นจริงมีจริงเราเรียนเราเรียนรู้ว่าเป็นมันก็รู้ว่ามันเป็นรู้ว่าเป็นการที่เราไม่ได้เป็นรู้แต่สิ่งที่เราเราไม่ได้เป็นรู้เกี่ยวกับเรื่องของนี้ผมไม่ได้เป็นวิธีการมาทำให้มันดีนั่นแหละเป็นเรื่องที่เป็นมีสิ่งที่เป็นที่ต้องเราเราเรื่องโบราณที่เราที่สุดรู้ที่สุดนั้นมีช่องพวกโบราณการที่เราเป็นแบบนี้เป็นยุคที่พอจะเป็นเลยเราเป็นความเป็นมีเชื่อที่เรียนยังตอนนี้รู้ทางชีวิตของตัวเองที่เราจะต้องเป็นเรื่องที่เป็นสิ่งที่เราจะต้องรู้ตอนนี้คือสิ่งที่เราจะต้องรู้เป็นเราจะต้องทำอย่างนี้มีความรู้ตัวนี้เราจะต้องเรียนเรื่อง When you see how you do it, you have the direct. Now, how do you know? You want to put it in the I'm going to apply to that. I think that you got all done. And here is something you find. You got it done. You got it done. They will be there. Being on square. So overall, One. Yes. E and two solution. No, they want to log B. They want to log B. We want to log B. Sorry. Top in sun. This will be story. No, not yet. 4.27.
你可以这样子，你也可以用像你们做的找 acceleration 找 distance。There are two ways to do it. Okay? There are two ways to do it. Okay, I give 3 minutes, then we continue next part. Be back in 3 minutes.
们做那几个，有啊，什么？什么意思？那我就已经那个走的，什么？对，对，有点这个什么，我感觉就是特别的平时很简单，对，有一个不会记得啊，这个你要上去年的初一的，不要走，啊，三层，你要很高标的，我给你看，问题然后就是嘛，所以说才先出个。我有没有忘记他们那个要的关系？有那个云端子在那个地方，有一个人讲的，对，关什么执行？也，但是我告诉你们，他们都是被他们两个自己有自己的，就是跳舞的话就不整齐哦，就是跳舞不整齐哦，然后。唱歌的话，哎呀，那个会说什么是哎，那个所以你看其他什么，你看就也是看到自己的，我是很多问题，就是看着你的唱歌的人发声啊，他的真的，分别的你的那个伟大啊，这种什么啊。有齐啊，这他们里面有的很齐啊，不会很乱那种吗？想要去打那种，就差点都。我觉得你要干那个哦，没有啦，妹妹的这个话，你可能加一个成本。干嘛？这是这样，还有可能性。都有。我玩创业，我真的不打，只能打出去。因为只是把合作的经过两个。因为他们两个嘛，他们一个唱歌，一个相声，他们唱歌的结合相声就，为什么你们觉得他们那样？因为整车的你说他们第一个是，他们那时候相声讲的东西，就是跟学生讲的不一样的，然后我们那时候是第一个。那个小空间，然后他们评审也坐在那边，他讲的时候，我们是全部人都在笑。我那我是第一个拍到有没有笑？有没有笑？他自己有没有笑？可是你这里是很憋那个，然后我常忘记了，我是那个，我是知道他学马，我也学瑜伽，但是瑜伽我刚刚。我有点记得他还麻将，然后他大学那什么，然后就会老师来，然后这个是麻将，那个是海报啊。可以拿哦，可以，然后麻将，然后特别不够，我觉得很好的经历。很好，那个他们我只教的猫头鹰。我如果说每个月我买一支，好的，真是要把生意，然后家里有一个干股啊，这个很确就是给哥的，给哥来说，梦回童年， 没这个，不知道这样子搞的一个工作，所以你们现在只是请下去啊，所以他们这里呈现出他们4个人嘛，他们就一个人负责一个机器。哦，所以这个是一个，你们介绍的挺是说他们这个名字来做名字。这样子你像我们班里的样子，知道呈现出你选的歌，这个歌。但是我打节奏也出去，那个，你用那个地方会，所以我也不对，我所以我就是你看了2年，我只看一点点，所以为什么所以我是看里面啊？因为这个什么，所以就是我高一很辛苦。这个第一点什么脑的？多一个年要进到学校，然后这个好像，然后他们喜欢说以前的那个，你知道吗？我参与者的那个知识比较很高，然后现在我去那你们可能，那我一直在发生很多事，我应该的，整个一天很敏感的东西，可能会。我总在看成做那个福利，对，我刚跟你讲，我来看看什么，哦，你这多一点，我讲那你跟谁呀？啊，你这是个什么？我不太有意思，再说讲一下。
Okay, right. A bit more, yeah. Everybody pay attention here. This one, I don't want you to miss. Energy conversion between potential and kinetic. I will take more like 5 minutes. Okay, so far 你知道 kinetic energy 啊 ？kinetic energy 是 half mv square. Kinetic energy 是 due to motion. You speed, you kinetic energy. The faster you move, the higher your kinetic energy. Then the next one is potential energy, PE. So mg h. This is due to position. If you are at a position that is higher from the ground, okay, let's say this box is lifted 5 meters, 5 kg. You will have potential energy. How much potential energy does the box have? Is calculated by mgh. So 5 times 5 times g is your gravitational constant. 260 joule. Raising the box to 5 meters. Hold it here. How much energy it stores? 250. I let go, it will start moving, dropping. Why? Because it has energy. Energy is the ability to do work. With the energy, it can do work by moving down. The higher I raise it, the higher will be the PE, because it depends on position height, okay, from the ground. 你的 H 是 measured from the ground. Okay, now take this two. 这个两个一起 is called as mechanical energy. Okay, mechanical energy 是什么？这个 PE 加 K, total of PE 加 K is your mechanical. Now let's take one situation. Here's a ball, 2 kg. I toss the ball from the ground. I give it a large speed initial u. The moment I throw it, let's say 100 meters per second. 1 second later, it's going to be 90, 80, 70, 60, 50, minus 10, because your acceleration is 10, deceleration is 10, right? So I give it initial velocity, that means here is 100, right? Up here is 90, 80, is speed decreases. That means this speed initial is the maximum speed. 如果这里是 maximum speed, then 这里的 kinetic energy 是 maximum. 这个是最大的。So at the start, the moment you throw it, the kinetic energy is maximum. Let's say 100. Okay, 100 joule. And then the ball rises up, the speed slow down, slow down, slow down. At the top, before turning back down, at the top it will be 0 speed. At that second, the speed will be 0. So speed goes 100, 90, okay, 50, 40, 30, 20, 10, 0. When it reaches 0 speed, that means this is the max height already. This is the maximum height. Now, 0 speed already, then the next second what happens? It will fall down, right? So that means this point is the maximum height. If I take the point at there, this point, what is my KE? KE is 0. 在那一瞬间，我的 KE 是0 because my speed is 0. 所以从一来100上到去0 in the process, KE decreases, right? KE decreases. Now, at the same time, watch what happens to the potential energy. Remember, the higher you are, the more the potential energy. Okay, at the start, when I tossed it, the ball is so close to the ground that we just assume it at the ground. So that means here the height is 0. Very small distance, I just take 0. Okay. So what is my PE? Potential energy is mgh, 0 joule. Then rising 10 meter, 20 meter, 30 meter to maximum height, max height. So at this point, my height is maximum, right? So my PE is also maximum. This one is 100 joule. So going from here to here, my PE increases. Here, if you see only the KE, 只是 focus 在 KE， 一来我们有100，上到去我们的 KE 变成0了。In the energy concept, it says what? Energy, you cannot destroy it. You cannot create it. You can only transfer, right? So if the KE from 100 goes to 0, decreased 100, where is the 100 gone? The 100 has been changed to your PE. So at the top, your PE now got 100. That is the conversion between KE and potential and kinetic energy. Okay, now, 看你的 mechanical energy. 我们先看在 bottom 啊 ，at bottom 我们的 mechanical energy 是什么？这边我们看到 KE increase, potential energy decrease, KE decrease, potential energy increase. So one increase, one must decrease. If this one decrease, then that one increase. So if I see mechanical energy at bottom, the mechanical energy is more PE 加 KE. At bottom 是多少 ？PE 在 bottom 的时候是0，加 KE 在 bottom 100。So my mechanical energy is 100. Compared with mechanical energy at top, 一样 PE 加 KE. Now my PE is 100, my KE is 0. Total is also 100. Does my mechanical energy change? No change in mechanical energy. Mechanical energy remain the same. What is changing? This one is changing. This one decrease, this one increase, but overall total, there is no change in the mechanical energy. So this situation only happens when there is no external force. Please remember this. When there's no external force, what force is acting on this ball? The gravity is acting on the ball, the weight. Is that the only one? Yes, we ignore the air resistance. If you include air resistance, this one will not be the same already. The weight is not external force. Air resistance is external force. Okay? So in a system, if you don't have external force, then we say mechanical energy is conserved. Yes, 意思就是说 remain the same 啊 ，remain the same。OK， 你可以把它想成在一个 system 里面，这个是你的 system 啊，你有 KE 100，你有 PE 50，这里我可以减20加20，这里减这里加。这里传送来这边，这里也可以传送回去，可是总共的一定是150 150，总共你的 ME 是不会变 ，always 150。Here you can exchange 50 go here, 30 go here, 30 go back. You can exchange, but the total is still 150. This is what we are looking here. Okay. Okay. So 从这边，我们讲 increase in okay, this is the conclusion 啦 ，okay, conclusion increase in PE 是等于 decrease in KE。或者怎么来 increase in PE 等于 decrease in KE, right? So if 20 transfer here, this one, 20 transfer from here to here, this one will decrease KE, this one will increase PE. Okay? Or I transfer back, decrease in PE, increase in KE, but the overall must be the same. Increase or decrease in PE, increase in KE. Now, please remember this. We will use this to solve all of the problems, right? All of the problems that has no external force. That has no external force. I give you one example. You do it here. Five kg ball. I dropped it 80 meters per second from ground. What is the maximum height reach? Assuming no resistance. Example, now 5 kg ball, I tossed it, giving it initial velocity of 80. Now I want to know what is the max height it can reach. What is the maximum height it can reach before dropping? Using the energy. I know going up, what happened to the KE? KE reduces. So if I start with KE drop, the PE rise. KE drop equals PE rise. How much is KE drop? How much is your KE drop? 这里是 half mv squared. Half 乘5乘80 square，上面是0。So how much is the drop? I repeat, at the start your K is half mv squared. At the top your K is 0, maximum height. How much is the drop? Half mv squared. Half mv squared is the drop. Okay, so for example, here is 100, here is 0. So the drop is 100. PE rise. 下面是0 ，PE 是0，上面的 PE 是 mgh。PE rise is mgh。这个是你的 max height，这个是你的 initial。所以拿到 half mv squared 等于 mgh。Then I will find my h. Meter. A ball is dropped from rest at a height of 12 meters. Calculate the velocity just before reaching the ground. Meter. Calculate the velocity downhill just before touching the ground. Dropping ball means K increase. K decrease. Right? Height reduces. That's why your PE reduces, decrease. Don't say me max. Okay, never mind. Because you see, K increase, half mv squared. Mg, this one you can cancel. Okay, so you don't need the mass. How much is K increase? 这边的 K 是0 ，rest 嘛，加到来的 K 是 half mv squared. So increase is half mv squared. This is final. Decrease is mgh. So half mv squared is 2 times. Let me know if you have any questions. Okay, 第六题 last. Next one. 6 and 7. Okay, ma. 6A, what is the magnitude of the constant force? The weight is the only one acting, the only force acting. 19.62. Okay, we use 10 and 20 lah. B, comment on the direction of motion and the direction of the force. Gravity is downward. Distance travel is upward. So work done by gravity is a negative, different direction. Remember what does negative work means? Taking kinetic energy away from the ball. So KE decreases. Now C 条你找 determine the speed when object has traveled 3 meter vertically upwards. 我们用 work done 来做 3 meter upward. What is the work done? Gravity 是 19.62 distance 是 3 meter. Okay, work done by gravity. Negative. Okay. So, in kinetic energy 也是58的差异。How much? Okay, last one is finding max height reached by object. 你要 reach 到 max height, 你的 kinetic energy initial is 100. Must all convert to potential, right? That's why I say here total amount of KE drop. How much total amount you can drop? 100. You have 100 to start with. To reach max height, which is becomes 0. So the total drop is 100. If the total drop is 100, then gravity must do 100 joules of work. Take away the 100. So we do like this. Another way you can do is, this is the drop in KE, right? Drop in KE. What about the rise in PE? Also, 100. Just now you learned that one. If I say total amount of drop in K is 100, where does it go? It goes to the KE. The KE is 100 equals to mgh. From here you find the h. Mg 2 bagi h 也是拿到5.10 meter. This one or this one. You still get the same answer. Yeah. Okay, we finish. We will continue next lesson. Please bring the paper on next one.